Welcome back. Now we are going to be looking at gas laws now. This is our second video on the introduction to kinetic theory of gases. In the previous video I explained what kinetic theory of gases entails. Now we'll be looking at gas laws. And remember, in the previous video I said that the only gases that tend to obey the kinetic theory of gases are actually gases that are called ideal gases or perfect gases. And you can only have the existence of ideal gases or perfect gases under standard or normal conditions, talking about standard temperature and pressure. All right. Now, looking at gas laws, there are so many gas laws, ranging from the Boyles law, the Charles law, the Avogadro's law, and the rest. But I will make it to be very simplified that there will be no question coming from the calculations involving gas laws that will be giving you issue anymore. So you just stay tuned and follow the series with me. Now, there are quantities that you need to understand very well in gas laws. And what are these quantities? First, you must understand pressure. Second is volume. And third is temperature. So the reason why I'm outlining this or outlining all this is because these are terms that will be commonly used in the course of our lesson. Talking about Boyles law, any law at all, you must see some of these terms being used. All right. Now, looking at pressure in your physics lesson, you ought to know what pressure is. It's actually force over area. Now, what is of utmost relevance when you are working with these quantities in gas laws is that you need to understand their units in terms of their unit conversions. Now, looking at pressure, pressure has diverse units. And what are some of these units? Pressure could be measured in millimeters mercury. It could be measured in atm, atmosphere. It could be measured in torr. It could be measured in bar. It could be measured in Pascal. It could also be measured in Newton per meter square. All right. So these are diverse units of pressure, and you ought to know how to convert from one unit to another. I'm going to show you briefly. Now, one atmosphere, one atm, is equivalent to 760 mmHg, millimeters mercury, and this one is equivalent to 760 torrs, and this is equivalent to 1.01325 bars, and this is equivalent to 1.01325 Pascal, and that is also equivalent to 1.01325 Newton per meter square. So you can take cognizance of this. It will be of utmost relevance during the course of learning gas laws. Then looking at volume. Now, volume, this one is for pressure, don't forget, is pressure. Then volume has diverse units as well, but the most commonly used units in volume is we have the decimeters cube or cubic decimeters, and then we also have the liters. Then we also have the centimeters cube. Then we also have the milliliters. All right. So, but I will just give you the units conversion. Now, listen. 1 liter is equivalent to 1 dm cube. 1 milliliter is equivalent to 1 cm cube. So what does that mean? It means that if I'm having 100 liters, I can also call this 100 dm cube. And if I'm having 10 cm cube, I can also call that 10 milliliters. You get the point? But then again, how can you now link the liters to the cm cube? So I can say 1 dm cube, 1 dm cube is equivalent to 1000 cm cube. So it means in 1 dm cube there are 1000 cm cube. I can also replace this with 1 liter is equivalent to 1000 milliliters. All right, so that's that about that. Then looking at temperature. For temperature, now you can actually pause the video and take down this stuff. For temperature, temperature has diverse units. Now, temperature in terms of its units, it could be in Celsius. Celsius is also called centigrade, or it could be in Kelvin, or it could be in Fahrenheit. All right. So looking at this Celsius, it has its own representation, symbolic representation. Then while this one is K, then while this one is degrees Fahrenheit. So you should know how to convert from a particular unit of temperature to another. Now, in terms of conversion of a particular unit to another in temperature, if you are converting from Celsius to Kelvin, you simply add 273. If I'm giving 20 degrees Celsius, if I want to convert to Kelvin, I will simply just say 20 plus 273, and that gives me 293 Kelvin. Amongst the three temperatures units, the one that is considered as absolute temperature is Kelvin. So this is absolute temperature. All right, absolute temperature. Then if you want to convert from Kelvin back to Celsius, of course you know what to do. You have to subtract 273. Just for example, let's say this one is my Kelvin and I'm told to convert back to Celsius. What should I do to this? I'll simply subtract 273. So it becomes 293 minus 273. That gives me, of course, 20 degrees Celsius. You get? Then what about when you are now converting from Celsius to Fahrenheit, or from Fahrenheit to Celsius? I can give you just a code that you can use. Now this is like more or less like an equation. But then again, if you are told to convert from Fahrenheit to Celsius, you can use this relationship. Degrees Celsius is equal to 5/9 times bracket Fahrenheit, degrees Fahrenheit minus 32. So you can use this and then you can easily get your Celsius when you are given the Fahrenheit. So it means anything you are giving for Fahrenheit, any value you are giving, you simply subtract 32 from it and then you multiply by that fraction 5/9. You get it in Celsius. For example, let's say I'm giving 40 degrees Fahrenheit and I'm told to convert to degrees Celsius. What should I do? I will simply just come to this place and then it becomes degrees Celsius is equal to 5/9 times 40 minus 32. So when I subtract, I'm left with 8. And of course, it becomes degrees Celsius equal to 5/9 times 8. And when you just do that, you get your answer. So that's that about that. So we've seen how we can convert from a certain unit to another unit in terms of these three very important quantities. Now, let's see the introduction to gas laws. Looking at the first gas law, Boyles Law. Yes, I said Boyles Law, not Boyle's Law. Now, of course, the girls are welcome. You understand what I'm trying to say? Meaning that it was actually postulated by a scientist named Robert Boyle. Robert Boyle. So let's start with the Boyle's Law. Robert Boyle was the scientist that actually worked extensively on the discovery of Boyle's law. Now, Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure, provided the temperature remains constant. So listen, in Boyle's law, you don't have temperature. Take note of that because the temperature is kept constant. What you have of Boyle's law is what? Pressure and volume. And from what I just stated now, the volume of a fixed mass of gas is inversely proportional to its pressure. Then temperature remains constant. Now looking at this, you can take your mind to your mathematics lessons on variation. This is actually an example of inverse variation, and you can easily introduce a constant with an equality sign to eliminate the proportionality sign, and that becomes V is equal to K over P. And then when you cross multiply to make K stand on its own, become K equal to PV. And of course, when you are relating more than one gas, you can go with this pattern. P1 V1 is equal to P2 V2. So you see where this formula came from, this relating or linking two or more gases. So it means that this P1 is initial pressure, V1 is initial volume, P2 is final pressure, then V2 is final volume. So that's actually the formula that is used for calculating Boyle's law. All right. Now you can use this as an illustration to understanding the relationship between volume and pressure. Now, volume and pressure do not love each other. They don't agree. Meaning that when you are increasing pressure, you are reducing volume. And when you are reducing volume, you are increasing pressure. When you are increasing volume, you are reducing pressure. Just like this. Now let's say this is actually my pressure, then while this one is my volume. Observe, if you move towards the right hand side, you notice that there was a decrease in the size of P, which in turn leads to an increase in the size of V, meaning that decreasing P is resulting in an increase in V. That means that a decrease in pressure is resulting in an increase in volume. Then when you are coming to this direction, a decrease in volume is resulting in an increase in pressure. So that's about it. Then you can actually have graphical representations for Boyle's law. Some of the graphical representations of Boyle's law, you could have something like this, where pressure is plotted against volume, and of course an increase in P will result in a decrease in V. Then you can also have another like this, and then you can have volume plotted against pressure. All right. So you can also have others too, but that's not really our main focus. Our main focus is on the calculations involving our gas laws. So let's start by looking at calculations, some questions on calculations involving Boyle's law. And let's see how we can apply that formula P1 V1 equal to P2 V2 to calculating questions related to Boyle's law. So on the board, we are having questions on Boyle's law. So we are going to see these questions and solve them. So you just pay attention as I run through the questions. Now, the number one question is, a gas occupies a volume of 5 dm cube at 2 atm. What volume will it occupy at 11 atm? What does this mean? It means that we are giving volume and you are giving pressure. You see the twist? So how do you know if a question is on Boyle's law? Because of course you won't be told whether it's under Boyle's law that you are being asked the question. No. But rather it is from what you see, the quantities that are given in the question, that you can use to know which of them you are to work with. In this case, we are giving volume and pressure. So it's obvious that there is no temperature. And that means that temperature is constant. And you know the only gas law that has temperature to be constant happens to be Boyle's law. Alright, now looking at this question, remember the formula, you outline the formula P1 V1 equal to P2 V2. And you bring out your parameters. Of course, a gas occupies a volume of 5 dm cube, meaning your V1 is 5 dm cube. Then at 2 atm, meaning your P1 is 2 atm. Then we're told what volume will it occupy, meaning V2 is unknown. What volume will it occupy at? Then the P2 is given to be 11 atm. So it will be very easy for you to just plunge in the values into this formula here and you get your answer. How? Your P1 is known to be 2. So 2 ATM in place of P1 times, then V1 is 5 equal to, then P2 over here is 11 times, V2 is now unknown. So put V2 there. That's what we are told to find. Then 2 times 5 of course is 10 equal to 11V2. So from here we can divide both sides by 11. Alright. So when we divide both sides by 11 in order to get our V2, V2 would now be, with the use of our calculator, we can actually divide and that becomes 0.9. So 0.9 dm cube. That's the answer. And it actually confirms the fact that the relationship between pressure and volume is inverse. And what does that mean? It means initially we were given in the question that the volume V1 was 5 while the pressure was 2. Now the volume is unknown while the pressure is 11, meaning that there was an increase in pressure from 2 to 11. So we are supposed to experience a decrease in volume because when you increase pressure, volume decreases. So that's the reason why we had this value, which is a lower value than the previous volume being 5. All right. So let's quickly look at question 2. Now looking at question 2, if the volume of a fixed mass of gas is doubled, what happens to its pressure? Of course, we are not giving any form of parameter here, but you can use your initiative to actually answer this question. First thing you do always is P1 V1, you bring out the formula P2 V2. Then looking at the question, he said if the volume of a fixed mass of gas is doubled, meaning that there was an initial volume that was doubled. So it means the initial volume V1 remains V1. The initial pressure P1 remains P1 because now if the volume of a fixed mass of gas is doubled, meaning there was an initial volume, what happens to its pressure, meaning the new pressure? So there was an initial pressure. So looking at P2, we don't know. That's what we are told to find. What happens to its pressure, meaning the P2? Then for V2, we are told that the V2 would not be the doubled form of the V1 because they said if the volume of a fixed mass of gas is doubled, there was an initial volume that was doubled to form a final volume, and the final volume happens to be what? 2V1. So double form of what? Of the initial. So what you simply do is just to substitute into the formula. Come back to that formula, our V1 remains V1, and of course our P1 remains P1. Let's go by the sequence. Then V1 remains V1. Then P2 remains P2, which is unknown. Then V2 would now be what? 2V1. Yes. And of course, common terms you cancel out. So you can cancel out this one. Then what are you now left with? Remember, we are told to find what? P2. So what do you do from here? You divide both sides by what? 2. And when you do that, it becomes over 2 and over 2. So 2 will cancel. Then your P2 is what? P1 over 2. And of course, you are aware that this can be rewritten as P2 equal to 1 over 2 P1, meaning half of what? Of the initial pressure. So it means that when the volume is doubled, then the pressure should be what? Halved. You understand it? So it's just like the Boyles Law relationship. So when you increase volume, you reduce pressure. When you reduce pressure, you increase volume. When you increase pressure, you reduce volume. So that's about that. Let's see the third question. So looking at the third question, if the pressure of 10 liters of a gas is increased from 2.5 atm to 3040 millimeter mercury, what will be its new volume? So you still bring out the formula P1 V1 equal to P2 V2. Now, if the pressure of 10 liters of a gas, meaning there was an initial volume 10 liters, is increased from 2.5 atm, meaning our initial pressure is 2.5 atm, to 3040. So it means our P2 is 3040 millimeters mercury. Then they said what will be its new volume, meaning V2 is unknown. But looking at this question very well, you get to know that the units of the two pressures are not the same. So it means you must work with a given unit for a given quantity. Now, since this one is in millimeter mercury and this is in ATM, we can decide to use ATM or we can decide to use millimeter mercury all through. So if we decide to use millimeter mercury, we have to convert 2.5 ATM to what? Millimeter mercury. But if we are using ATM, we have to convert 3040 to ATM. But it's best we just use ATM. Remember, from the unit conversions I gave, I said that one ATM is equal to what? 760 millimeters mercury. So if one ATM is 760 millimeters mercury, then how many ATMs would now make up that 3040 millimeters mercury? Of course, you can use the normal linear pattern. When you cross multiply, you are left with what? X times 760 equal to 3040 times 1. And when you do that, x becomes 3040 divided by 760. And when we do that, it becomes 3040 divided by 760. That gives us 4. So it means our x is 4 ATM. So we are going to be working with the 4 ATM here. So we are good to go. So we now substitute all the parameters in the formula, and our P1 of course is 2.5. So in place of that, we'll now write P1 2.5. So 2.5 times, then our V1 in the question, our V1 is 10 liters. Then our P2 we are working with 4 now, 4 times, then our V2 is unknown, V2. So we now have to divide both sides by 4. And when we do that, then our V2 will be equal to 2.5 times 10 over 4. And when we do that, of course, 2.5 times 10 is 25. So 25 divided by 4, that's 6.25. So our volume is 6.25 liters. All right. Remember that the initial volume here was in liters. So your final volume should also be in liters. So observe it. Initially, the pressure here was 2.5, having a volume of 10. So the pressure was kind of increased to 4. So there should be a reduction in what? In volume. That was the reason why we had 6.25, lower than 10 liters. All right. So it's my hope that you've been able to understand the calculations. You can try your hands on other calculations on Boyles Law, and you'll be very happy, pleased that indeed you're able to attempt them correctly. All right. So in our next video, we'll be looking at Charles law and other laws as well. Thanks for watching, and don't forget to subscribe, hit the like button if you like this video, and share the video to your friends to make them to be aware of the video, and as well, for them to be actually prepared for their exams. Thanks for watching, and God bless.